right? Just tie the roof beam. This is actually tied to the roof, the dotted line. Okay. And the same applies to the back. These are called tie. And you can see those beams are very slender. The beam 好幼 steel beams. And they try to put a lot of holes there. Why? To make it lighter, save material, save weight. If the whole thing is lighter, then the foundation is lighter. 當你上蓋慳咗物料，地基都自然慳咗物料。當你上蓋重，下身自然都會重，地基自然都重。重嘅意思就係多物料，物料即係錢。So there's always a wish to make your structure lighter, make it more effective, lighter. So that's a very common roof system for stadiums, swimming pool, track field, whatever. Some outdoor track field, tennis court, whatever. That's a very common roof system. Try to make the thing lighter. And if you go over to the next slide, you can see a zoom-in view of those beams underneath. Right? Just closely look at those beams. You can see that there are lots of holes. We'll come back to this slide in week 11, I guess. So the thing is, you can see there are lots of holes there to make it lighter, save material. So here I just try to redraw a little hole here, let's say this one. When you try to make holes in beams are actually very common。即係好多大廈都有㗎啦，嗰啲陣好多時我哋開窿係俾啲 building service 嗰啲 ducting 嗰啲嘢通過。But here of course it's not for building service purpose. This is just for saving weight. But if you want to make an opening or holes in your beams, always try to make it right at the center. So what I mean here, I try to redraw this little part. Right, so looking at the elevation view, right, looking from here, that's the top of my beam. That's the bottom of my beam. That's the center line of my beam. If you want to make an opening, always try to make it right at the center. If I draw a cross-section of this beam is an I-beam, so it looks like if this is my section AA. That's my AA. So you try to make a hole right at the center. Why? There's actually a structural reason why, but for here, for the time being, I just explain in layman's terms. Because in the center of the beam, this part of the beam is the least stressed area， 受力最少嘅地方。當然你開個窿梗係開喺就受力最少嘅地方。So don't try to make your hole at near the top of the beam or near the bottom of the beam. Try to make it right at the center. And we will come back to this. Why is it least squared? So least stressed in a few weeks' time, not today. Right, so a lot of things in structures, it's about geometry. Okay, and for making holes, usually we try to make a circular hole. We try not to make rectangular holes or triangular holes. Because if you try to make a, maybe I draw it here. If you're trying to make a rectangular hole like this, at the center. If you try to make a rectangular or square holes or a triangular holes with corners, the problem is at those corners. Those corners will attract a lot of stress. Right? So try to avoid corners in your opening. So the only geometry without corners, obviously, is a circle. Or sometimes it could be an ellipse, 橢圓形都得嘅. But there's no reason why you make an ellipse. Why not just circle to make it simple? Right? So try to avoid geometry with a corner. Those corners will attract a lot of stresses. 會受力好大嘅呢啲位。So that's why we prefer to make a circular opening. But sometimes in residential buildings, sometimes a rectangular opening cannot be avoided. 有時你係被逼一定要開個長方形，因為嗰條 duct 嘅 building service 有啲管係咁嘅形狀，你整個圓形都變得好大。Right? This one is 開放博物館。Right, this is a two-dimensional, a 2D two-dimensional surface, a fibre. It's a fibre, a stressed fibre, 拉行咗。Or the layman terms it stretched fiber, two-dimensional. It's a two-dimensional element. And combined with all these cables trying to stretch it, right? You need to stretch it to form this beautiful surface for the roof. And the principle behind it principle behind it exactly as the same. The roof is exactly using exactly the same principles as your umbrella. The most important component of this umbrella is that fabric. It's not a normal fabric in the sense that it's stretched. 拉行咗㗎嘛，唔係點會係把遮呢？ And why is it stretched? Because there's a metal frame underneath. 呢個支架最大嘅理由。 唔係撐住嘅，係要拉行嗰把呢塊嘢。Okay, otherwise it's not an umbrella. Okay, that's the reason.
Okay, and same principle here. To form that curved surface, as a rule, to cover what's underneath, you need to stretch it. Okay? So that's the reason for that thing. So the principle or the principle behind, you can think of it as an umbrella. It's a stretched fabric, right, by means of this metallic cable system, just like your umbrella, exactly the same. Right, so the last one before a quick break is that thing is again a roof for a stadium. This is a concrete roof. Right, it's supported by a series of columns at the back. You can see there is a series of columns at the back. Right, so the thing about this what is special about this roof is it's a quite a long span roof. If I draw, if I look at it from this way, it would be something looks like that, with a column supporting like that. So I can demonstrate using this paper. Suppose this is your roof. Just a piece of concrete. And you are trying to hold this thing by a series of columns at the back. So it's exactly like what I'm trying to do. You try to hold this thing up by a series of columns, a support at the back. It's not easy, even a piece of paper. Supporting nothing, its own weight. Only its own weight. But even to support its own weight is not easy. Right? So what are the possible options? Option one, you increase the thickness. Fine. That means more material, heavier, cost money. That's possible, but it's not a good option. Option number two, can we put columns in front? Can we put columns in front? Is that a possible option? It's a possible, but stupid option. This is a stadium. People are supposed to sit here and watch games, right? So you should not put columns in front. That's a stupid option, right? So the better option is, again, to do with geometry. Don't use a flat piece of thing like that. Try to fold it, 接起佢. If you look at more closely this face, the roof actually is not a flat concrete surface. It looks something like this. It's like a sheet pile. You heard of this before. So it's like that thing. So instead of having a piece of paper like this, you try to fold the paper with a cross section like this. Then you can hold it easy. Right? Same material. I did not change the material. I did not change even the thickness. I did not change the layout. I only changed the geometry of the cross section. Instead of a flat surface, I fold it. Then it's easy to hold and easy to stand up like that. No problem. right? So everything has to do with geometry. So that's why this roof, there's a special name for this. 呢個咁樣接起咗嘅 it's called corrugator. That refers to things like this. That's called corrugator. Right, so let's take a 3 or 4 minutes break and then we'll come back to say a few more slides.